Our next chapter is on quadratics. Do me a favor and try and solve this equation. Press the pause button, write it down, try and find the value of x that makes this equation true. I'm going to talk through it in just a second. My guess is, as you tried to solve this, you thought about trying to get the x by itself. So like you added 10 to both sides to get 2x squared plus 6x equals 14. And maybe you realized everything could divide by 2, and that got you x squared plus 3x equals 7. And then you thought, I don't like, okay, maybe I'll subtract this 3x from both sides, and that got you x squared equals negative 3x plus 7. And then you wanted to square root both sides to get rid of the square. And so you kind of got x by itself, but there's also still an x over here, and we don't actually know what x equals. We know x in terms of something else. Like if this is a 2, then this is a 1, and 2 does not equal the square root of 1, so the answer's not 2, obviously, and that was just a guess. X could be, right now, x could be anything. Trying to solve this equation here, however you did it, is probably not happening because this equation has 2 variables in it. Everything you've solved, well, most of what you've solved in Algebra 1 in previous classes had 1 variable. Solving equations with 2 variables takes some doing. It's quite more complicated than just solving with 1 variable. So let's talk about how to solve with 1 variable first. Do I have a thing over here somewhere? No. Solving an equation like this, we have to go to work our way up to that. So first let's talk about solving things like this. Both of these equations done, you have just 1 variable. You know, whenever you do simplifying or evaluating, you do the order of operations, which you often call PEMDAS, or please excuse my dear Aunt Sally, where you do parentheses, exponents, multiply, divide, add, subtract. And I put the MD and the AS in brackets because they go in order of whichever comes first, left, or right. Well, you often use SADMEP, which is the order of operations backwards when you're solving. You might not have thought of it this way, but if I'm going to try and solve this equation here, I want to first see if I can get rid of any addition or subtraction. I don't want to get rid of this because it's inside a parenthesis. It's kind of stuck there. But I can get rid of this. So I start by subtracting the 2 from both sides. And I know you know how to solve this, so I'll go through it a little quickly. That gives us this. Then I could distribute this 3 if I wanted to, but next I'll deal with the multiplication or division. In this case, I'll get rid of the multiplication by dividing. So I get x minus 5 equals 9, then I'll add 5 to both sides, and that gives me x equals 14. And in this case, I dealt with addition, subtraction, multiplication, division, and parenthesis. There was no exponent. Same thing here. This has an additional square on it. I'll start by doing the addition, subtraction. Divide everything by 3. Please note, I cannot distribute this 3 because of this square. I could have distributed this 3 because there was no exponent. But because this has an exponent, once you start distributing, what you're really doing is simplifying or evaluating, depending on which, in this case, simplifying. And if you simplify, you have to follow the order of operations, which means I do the exponent first. But I don't want to do the exponent first because x minus 5 squared is not x squared plus 25. X minus 5 squared is x minus 5 times x minus 5. Please stop making that mistake. So I'm just going to get rid of the stuff around the square. So we divide everything by 3 to get x minus 5 squared equals 9. Well, now, to get rid of the square, to undo the square, the inverse of a square is a square root. So I'll square root both sides of the equation. And this leads me to x minus 5, and the square root cancel each other, so there's no power anymore, and the parentheses can go away at this point. X minus 5 equals positive or negative 3. When you square root both sides of an equation, there's a plus or a minus. I will now add 5 to both sides, so we get x equals 5 plus or minus 3. I have to do this twice. 5 plus 3 is 8. 5 minus 3 is 2. Then I can plug both those answers in and check them. So if I plug in an 8, 8 minus 5 is 3, 3 squared is 9, times 3 is 27, plus 2 is 29. So the 8 checks, plug in a 2. 2 minus 5 is negative 3, squared is 9, 27, 29. They both work. If there's just 1 variable, solving these by square rooting is rather simple. So if you want to take a second to pause this and work through these problems, that would be encouraged. Solve and check, and then when you're done, see how it goes. If you get some things off from what I got, that's kind of an issue. Screw up both sides. X equals plus or minus 5. These are both easy to check. You plug in 5 or negative 5 and you square them, and you get 25. Now I want to get this thing by itself first. So I'm going to add 19 to both sides, and that gives me 4a squared equals 49 divide both sides by 4, and that gives me a squared equals 49 over 4, which is 7 over 2. Plus or minus. Oh, wait, I'm sorry. A squared is 49 over 4, and I'm going to square root both sides. I don't want to skip that step, which I did. Square root both sides. A equals plus or minus 4. The root of 49 is just 7. The root of 4 is 2, so A is plus or minus 7 halves. I can plug in 7 halves to check that. 7 halves squared is 49 fourths. I know that because I found it right there. 49 fourths times 4 is just 49, minus 19 is 30. I want to get this by itself. So I divide everything by negative 2. I cannot distribute that negative 2 because of the parenthesis. So x plus 4 equals 4. So now I can square root both sides, and that gives me x plus 4 equals plus or minus 2. Subtract a 4 from both sides. X equals negative 4 plus or minus 2, which is negative 4 plus 2 is negative 2, negative 4 minus 2 is negative 6. X equals negative 2 or negative 6. Plug those in to check them. Negative 2 plus 4 is 2, squared is 4, times negative 2 is a negative 8. That one works. Plug in negative 6. Negative 6 plus 4 is negative 2, squared is 4, times negative 2 is negative 8. You can check these really quickly when they're clean, easy whole numbers. Maybe you can't do it that quickly, but you can still go through and do it. Is this the exact same problem? It is not. We divide both sides by negative 2. We get x plus 4 squared equals negative 4. Now we square root both sides. And you don't have a square root of negative 4. There's no square root of a negative number. There's no real square root of a negative number. Whenever you have a square root of a negative, this means you have no real solutions. So it's very possible to get equations with just one variable that have no real solutions, because at some point you might have to square root a negative. If you ever square root a negative, that means no solutions. Now, you might note, this didn't start as a negative over here, but it was still solvable, and this did start as a negative over here, and it wasn't solvable. So you can't always just look at a problem and tell if it can come out to real solutions or not. There are ways you can do that, and there's actually methods you can follow with some forms. But here's how I think of it. We know this is going to come out positive, because anything squared, any real number squared, will be a positive number. If you multiply some positive number by some negative number, it can't come out to a positive. So this one, if we wanted to have some foresight and kind of pause and look at this in advance, we could have seen there's no real solutions. When you're square rooting, what it really means is you're asking, so like say we have 16 square root. We're asking the question, what number times itself equals 16? So this is, of course, 4, because 4 times itself gets you 16. And so you can't have a square root of negative 9, because there's no number when multiplied by itself that gets you negative 9. Like 3 times 3 is 9. Negative 3 times negative 3 is also positive 9. And if we did 3 times negative 3, that's not the same number times itself, so there's no real square root of a negative number. One thing I want to clarify that a lot of people get confused. This is just calculating the square root of 25. So this is asking for the positive square root of 25. This is just 5. If I wanted the negative square root of 25, I would put a negative in front, and that would give me negative 5. I don't do a plus or minus here because this is evaluating. This is me just finding the numerical value of this expression. Over here, I am solving. When you're solving, your goal is to find every possible x that makes the equation work, that makes it true. Well, the reason that this has a plus or minus is because when you square root both sides, it's possible that x could be 5 or negative 5. There are two solutions when you're solving. So if you take a square root of both sides, that's when you get a plus or minus because you're solving. But if you're just calculating some square root, then it just comes out to the positive or the negative, depending on which way it was written and what it was asking for. Now you might wonder, why do we even bother worrying about that negative sign at all? Why do negatives really matter? Matter. I didn't even mean to do that. Have you ever heard of antimatter? This is pretty interesting. Antimatter is, I'm going to describe this very poorly. Not quite the opposite of matter, it's the anti of matter. If you take antimatter and matter and combine them, they basically annihilate each other and release energy. and it's something that was discovered or first theorized mathematically. A guy named Schrödinger made up this equation for matter, and then this other mathematician physicist, whose name I can't remember, Durkheim or something like that, found that while working with this equation, and it has a whole bunch of symbols that we don't really know and recognize, and I looked at it just it's a mess, but also quite cool. While working with this equation, at some point he had to square root to solve. And in the process of square rooting, there was a plus or minus. And this physicist mathematician looked at this for a long time. I was told it was about 3 years, where he just had this equation and didn't know how to reconcile the fact there was a plus or minus. And at some point, he finally realized, oh gosh, there must be antimatter. There's a positive type of matter, and there's a negative type of matter. And it turns out he was right, and antimatter can be created in labs, and it's part of what CERN, the Large Hadron Collider, is working with way out in Europe over there. And it's really quite incredible, and it was all discovered through this plus or minus. So you kind of enter the upside down and find two different worlds of matter and antimatter, the plus and the minus matter. You only have one variable, then you can solve with just SADMAP. If you have more than one variable, you're going to need some other options to be pursued, which we'll talk about later. Today we just dealt with one variable. Okay, the last thing I want to talk about in this brief little section, which is just going to be like review of things going into quadratics, or chapter 4, is how to simplify radicals. Because we're dealing with quadratics in this chapter, there's a lot of x squared, which means a lot of square rooting of things, and we got to be able to simplify radicals later on in the chapter. So 80, I want to think about what are perfect squares that multiply to 80. For example, 80 is really 4 times 20, and 4 is a perfect square. And then 20 has another perfect square, and it also has a 4. 20 is 4 times 5. So this 4 here just kind of dropped down to here, and the 20 became a 4 times 5. And now I can split this up into 3 different radicals. Root 4 times root 4 times root 5. Root 4 is just 2, and this is 4 root 5. I think this is a very healthy way to think about how to do these types of problems. You think, what is the biggest perfect square that I know goes into 80? In this case, because I had 2 4s, I actually could have just done 16. But I didn't see that right away. And so, like, square root of 120, I don't have to do the biggest perfect square, I just do any perfect square. Well, 120 is 4 times 30. I know 4 is a perfect square. 30 can't break down, 30 is just 15 and 2, so this is going to be 2 root 30. That's one wonderful way to handle these problems, and I think if that way makes sense, do it that way. But you might have also seen a factor tree. A factor tree is where you take a number and break it down into its prime factors. So 120, well that's, 2 and 60. And 60 is 2 and 30. And 30 is 2 and 15. And 15 is 3 and 5. Once you're at the ends of the factor tree, you've got prime numbers. So this really means that 120 is 2 times 2 times 2 times 3 times 5. Well, I'm looking for pairs of numbers that I can pull out. The pair here of 2 comes out. It leaves the house. And then I see, are there other pairs? Well, 2 and 3 don't make a pair, 3 and 5 don't make a pair. Pairs have to be the same numbers. Those 3 numbers don't have pairs. They stay behind. This becomes 2 root 30. It doesn't matter if you do 2 and 60 or if you do 12 and 10 out of 120, because then 12 is just 2 and 6, and 10 is 2 and 5, and 6 is 2 and 3. You still have 2, 2, 2, 3, 5. It doesn't make any difference how you go about it. So 200 I can think of as 2 and 100. 100 I know is 2 tens. 10 is 2 and 5, and that was a really weird 10 up there. 10 is 2 and 5 here also. Here's a pair of 2s. Here's a pair of 5s. This 2 has no pair, so the pairs leave, and the thing without a pair stays behind. So this guy stayed inside the radical. This pair here, and this pair here matched up. So this is 10 root 2. I tell a silly little story to my students when I first show this to them in class. I say, we're at this party, okay? Inside this house, there's some party, and let's pick a bigger number. Let's pick the number 400. Nah, let's do 420. I've got a party with 420, and let's all pretend like that's not funny. 420. Well, okay, we look at this house, look inside the radical house, and it looks like there's 420 there, but let's break it down. It's usually there. There's a 2 and a 210, and 210 is 21 and 10, and 21 is 7 and 3, and 10 is 2 and 5. So there's a 2, a 7, a 3, a 2, and a 5 at this party. And they're hanging out before going to the dance. And in fact, if you want to know which dance they're going to the square dance, because I'm super great. They're going square dancing. And to go square dancing, you have to have a date. You have to have a pair. Well, these twos, they pair up. They hop in the car and they leave. But the 7 and the 3 and the 5, they all don't have dates. So they stay behind. So the 2 comes out as one couple. Even though there was 2 2s, they come out as a couple, because what we're really finding is the square root of 4, but the square root of 4 is just 2. So we get 2 root 210. That can't be right. 2 root 105. 7 times 3 times 5 is 105. So the things that have dates come out and go dancing. The guys that don't have dates stay home. And don't feel bad for the people without dates. They don't mind. They would rather be home playing games anyways, so everything's okay. So who was at this party here? It was a 4 and a 20. 4 is 2 and 2. 20 is 2 and 10. 10 is 2 and 5. Here's a pair of 2s. Here's a pair of 2s. The pairs come out and they multiply. 5 is watching Netflix at home. It's 4 root 5. 105. I think we actually know this one can't be done, because there's a 105 right there. 105 is prime. But let's see, it's 5 and 21. 21 is 7 and 3. None of these people have dates, so this is already simplified. It's root 105. Pull out perfect squares and square root them. Things that don't have perfect squares stay behind, and you've simplified. Thanks for watching. Till next time. Hey, thanks for watching. I hope that was helpful. If you have any questions, leave them in the comments down below. There can be questions about the video you saw here or anything else in math I'm happy to help with. Subscribe if you'd like to watch more videos or see other updates as they come. I'm going to try to run through all of Algebra 2 Trig and then eventually hit more classes like Algebra 1 and Geometry and Pre-Calc and everything else. If you have questions about stuff covered that's not in this video, still let me know. I'm happy to help. And finally, if you're not one of my students taking the class, but you found the video and are watching it, or maybe you're a teacher and are watching it, you can buy the curriculum and buy the worksheets to go through it. That's found at the website listed down below also. So again, thanks for watching. Have a wonderful day.